Question 1 starts with you sort of rehashing the rules of when a Poisson can be used, and the sorts of things we're looking for here is independent events. We're looking at singular events. They happen one at a time. We're looking at for constant rate that says it's 2/5. So those are the sorts of things that we'll be looking at for that bit there. But we're doing a Poisson hypothesis test. And the suggestion here is, and I'm going to do it fully rather than taking bits out of it, we're suggesting that the mean here, I put a mu there, or it could be a lambda, we're being told that the mean is 0.4, 2/5. And our alternative is, because it's two-tail, we're saying it's not 0.4, and that's why it's two-tail. If it was just greater than, it would be more than 1.4. 0.4. It's a 5% test, so because it's two-tail, we want 2.5% at each end, 0.025 at each end. And we're doing them we're doing this in a 10-minute period. So if this is per minute, I'll times that by 10. So assuming H0, then H is a Poisson with a mean of 4. So what we're going to do now is I'm going to grab the calculator here and I'm going to go for the lower end. Let's see what we need at the lower end. So I'm going to start at 0 because the lowest you could possibly is 0, and 4's, okay, let's try 2 here, shall we? And the probability of, the mean here is 4. Let's try. The probability of being from 0 to 2 is, wow, absolutely massive, far too big. So I'm going to bring it down a bit. Let's go 0 to 1. And even that's too big. I'm going to write that one down though. The probability that x is less than or equal to 1 is 0.09. Much, much, much too big. So actually, I think the lower end, it's just 0. The probability that x is equal to 0 is equal to 0.0183. So that's 1.8% down the lower end. Let's go up the upper end though. So what do you think? So what should we guess at to start with? So should we go more than, I don't know, we're going to go up to 9. Let's go, I don't know, I'm guessing, let's go 8. Oh, that was a pretty good guess to start with, wasn't it? So I went more than 8, greater than or equal to 8 is 0.05. That was too big. So let's go a tiny bit bigger. Let's try 9. So I'll put a 9 there. And look at that, 0.0214. So look, that is the best one we could have. That is the closest to 0.025. It's actually lower than 0.025 as I wanted. So my critical region is x is equal to 0 at one end. So if there turned out to be no phone calls, I would say this was wrong. Unioned with x is greater than or equal to 9. If I have 9 or 10 or 11 phone calls, I would suggest that this wasn't necessarily true. Anything in between, like 1, 2, 3, 4, 5, 6, 7, or 8, you would actually say, well, you know what, it could be 4, I'm not quite sure. Let's go on and do part D, no, the actual significance. The actual significance are these two numbers added together. So if you add those two things together, I get 0.0397. So we wanted to do a 5% test. We've ended up doing a 3.97% test for that bit there. Part D. Part D says, well, what actually happened was 8 emails. So 8 emails were received. That is not in the critical region here. So if it's not in the critical region, then I'm going to say we do not reject H0. Really, we believe them. It probably is for 8 emails. We haven't got enough evidence to reject H0. And then E. We've got to do a whole thing again. Let's pause that. I might do a new video for it.